Looking at the sizes of ions gets a little bit trickier, and we're going to have to be sure that we are comparing apples to apples and oranges to oranges. And so for that reason, we are only going to compare isoelectronic ions. So that means that we're going to look at ions that have the same electron configuration. So for instance, if I look at fluorine minus, oxygen 2 minus, sodium plus, or magnesium 2 plus, these all have the electron configuration of a neon atom. So since they all have the exact same electron configuration, they have the electrons, their valence electrons are all in the same end shell, and they have the same amount of core electrons, and so the shielding to those valence electrons are all the same. So that means that the only factor that's going to matter when we think about these isoelectronic atoms is what is the charge on the nucleus. So for fluorine, we have a charge of 9. For oxygen, we have a charge of 8. For sodium, we have a charge of 11. And for magnesium, we have a charge of 12. So that means that these 10 electrons, they all have 10 electrons. These 10 electrons in each one of these ions are going to get pulled towards the nucleus, but the larger the charge on the nucleus, the stronger that pull is going to be. And so this has the strongest pull, so this has the strongest Z effective, is the largest. And this one has the smallest Z effective. Z effective is the smallest here. And so these 10 electrons that are in magnesium 2 plus feel the strongest pull because that has the largest nuclear charge, and so this is going to be the smallest ion. And this oxygen 2 minus has the smallest number of protons in the nucleus, so those 10 electrons are attracted least to the oxygen nucleus, and so this is going to be the largest ion. And so for ions, we're only going to compare isoelectric ions. We're not going to try to compare ions that don't have the same electronic configuration. And so what matters only is what the nuclear charge is. The higher the nuclear charge, the more strongly those electrons are pulled towards the nucleus, and so the smaller the ion is. And the lower the nuclear charge, the less strongly those electrons are pulled towards the nucleus, and so the larger the ion is. Notice that it's always going to be the case that the largest negative charge is going to be the largest ion, and the largest positive charge is going to be the smallest ion.